Hello, I'm Mae Jemison, and it is my privilege to be with you today. It is a privilege because you are sharing with me your time. And time is the one truly irreplaceable commodity that we have at our disposal. But time comes with a paradox, because while our time is limited, 86,400 seconds in each day, it offers infinite possibilities because we get to choose what we want to do with our time. So thank you for choosing to spend this time with me. I want to share with you a journey in the pursuit of the extraordinary. What do I call the extraordinary? I call extraordinary a world in which we all people, get an opportunity to reach their full potential and to contribute beneficially to their society and to this world at large. And you know what? That's sort of what we envision when we consider the promise of big data and its impact. However, before we get started, I first want to provide you with a little bit more about my path arriving here today. That way, perhaps you'll understand a bit more about what shapes my comments. As an astronaut, Peace Corps medical officer, physician, chemical engineer, environmental studies professor, business owner, and educator, I have been exposed to the most advanced technologies and bountiful economic resources that often were alongside a woeful pittance of human compassion. And I have been with people who have persevered in conditions that would try all of us mentally and physically. And they use technologies that served them outstandingly for thousands of years. And these people would share with me all the joy and hope in any food they had. I grew up during the 60s, at least a part of my childhood spanned the 60s. I have to tell you, I wasn't always a wannabe hippie, and I resented the fact that I just was really too young. Sort of like the wannabes today. But anyway, what strikes me about the 60s was not what people call anarchy. I don't believe that was it. I saw the 60s as a belief that everyone could participate. There was this willingness to try. There was this openness to understand the world and creativity. The world was changing from decolonialization to the modern rights, civil rights movement to do new music. The tension in the world was about growth and change, and creativity was at the center. The 60s left me with a problem. You see, I lived and breathed sciences, and I wanted to go to outer space, and I loved the arts. Growing up, I wanted to learn about and explore all kinds of things. However, I encountered dilemma after dilemma as folks attempted to understand me either as a budding scientist or a budding dancer and artist. You see, as a little girl and a teenager, I designed and made doll clothes. I loved the idea of being a fashion designer. I took studio art and ceramics classes, and I danced. I loved Alvin Ailey, Sid Charisse, Lola Falana, Jerome Robbins. At the same time, I avidly followed the Gemini and Apollo programs. I knew line and verse of what would happen on the mission to the moon. I was an original series Star Trek fan. I had science projects. I took tons of astronomy books out of the library. I studied calculus and philosophy, and I pondered the concepts of infinity and the Big Bang. In college at Stanford, I was a chemical engineering major and what a friend called a closet pre-med because I didn't decide to go to medical school into my senior year. But half the folks thought I was a political science major and into the arts. And I was. I was Black Student Union president. I also majored in African studies. And of course, I danced all the way through college. In fact, my last quarter, my senior year, saw me juggling separation processes, logic, and nuclear magnetic resonance classes, and producing and choreographing a dance production called Auto Shadows, and working on the lighting and the costume design as well. I ended the year with the dilemma: do I go to New York to try to become a professional dancer or to go to medical school? Well, my mother helped me solve that problem, but that's a whole nother story. But you see, even as I started NASA, I had been working on building a business in African arts and design, but I just ended up collecting African art and learning the switches of the space shuttle. Astronauts are allowed to carry souvenirs into space with them so that they can share the experience with others upon their return. So when I went into space, I wanted to carry things to include other people. I carried up an Alvin Ailey poster of Judith Jamison performing the dance Cry for Black women everywhere. I carried up a Bundu statue, B-U-N-D-U, which was for Women's Society in West Africa. I carried up a certificate for Chicago public school students to promise to do well in their math and science. And sometimes when folks looked at what I took up with me, they asked me what was the connection. The connection of them was that they represented the same thing to me. They represented human creativity. You see, the same creativity that's required to conceive and build and launch the space shuttle, it springs from the same source as the imagination and the analysis it took to make the Bundu statue and the ingenuity it took to conceive and stage the dance Cry. Each are different manifestations of human creativity. They're incarnations, avatars, if you will, of creativity. And it's vital that today in our society, we reconcile in our minds the relevance of these avatars because we need to take advantage of them to solve our problems. So let's talk about this a bit. The difference between the arts and sciences is not that the sciences are analytical and the arts are intuitive. Think about it. That famous equation, E equals MC squared, it required an intuitive leap and then the analysis to see if it was correct. Dance requires a desire to express the jubilation light, but then you must analyze the movements and the lighting to make sure the message gets across. The difference between the arts and sciences is not deconstructive versus constructive either. Lots of folks like to say science is deconstructive. It takes things apart. And yes, some subatomic physics is deconstructive. One literally tries to tear an atom apart to see what's inside. But sculpture is deconstructive. I have a wonderful friend who told me that a good sculptor sees the shape residing in the clay and removes what hides that shape. Biotechnology is constructive. You take constituent amino acids and you want to build a protein that has the characteristics you want. Arranging a piece of music for an orchestra is constructive. You build layer and layer upon the music to come up with a song. In fact, we use constructive and deconstructive, analytical and intuition in all phases of the arts and sciences. So what goes on here? Here's how I see the arts and sciences. They're not different sides of the same coin or even different parts of a continuum, but they're manifestations of the same thing. They're different quantum states, or to be more 21st century, we could say they're different harmonic resonances on a superstring. They spring from the same source. They are our attempt as humans to build an understanding of our place in the universe. All the universe inside of us, that's internal, and that's external to us. The sciences are manifestations of our attempt to express, to share our understanding, our experience, our influence the universe that's external, that's not peculiar to us as individuals. The universe as it can be experienced by everyone. Experiences that are not peculiar to the individual. I believe that the arts manifest our desire, our attempt to share with or influence others through experiences that are peculiar to us as individuals. Let me say these again. Sciences provide an understanding of a universal experience, and the arts provide a universal understanding of a personal experience. I bring this up because the need to understand the tension between the arts and the sciences exists. As anthropologist and preeminent writer of 20th century, Zora Neale Hurston stated in Dust Tracks on a Dirt Road, Research is a formalized curiosity. It's a poking and a prying with a purpose. Research, poking and a prying with a purpose, is exactly the reason for teams. That's the reason I bring this up. When we try to answer a question or even ask a question or to solve problems, we usually have a purpose. And that purpose is born out of our experiences and our understanding of the universe. The universe internal and the universe external. Poking and a prying with the purpose. Research and its outcomes are at the heart of the reason we need purposefully inclusive, diverse teams if we're even reasonably have a chance to address the major challenges in our world today. This is because the questions to be asked, the research acumen required, the solution sets that must be formulated, the range of design capabilities demanded, the social reach for successful implementation, the assessment or maintenance of any solution. None of these things exist in just one discipline, nor can any of these things be ascertained effectively through a single perspective or a single view of the world. Teams and data. Remember that image of a black hole that was released about a year or so ago? A scientific team made history when they detected gravitational rays from the collision of two black holes that supported the final prediction of Einstein's general theory of relativity and demonstrated a completely new method of observing the universe. That's what this team did. Over 200 researchers across observatories and facilities worldwide were required to image a single black hole. Think how narrowly scoped this was, but how many methodologies were required. So I think that'll get us started on our journey to pursuing the extraordinary. Currently, I work with and lead a project called 100-Year Starship. And 100-Year Starship is an independent private organization to ensure that the capabilities for human travel beyond our solar system and to another star exist within the next century. 100-Year Starship uses the incredibly difficult challenge of interstellar journey to foster radical leaps in knowledge, technology, innovation in human systems, using that to transform life here on Earth and beyond. Central to this whole enterprise is building a public appreciation to the remarkable impact of space exploration, past, present, and future. And 100-Year Starship engages engineers, artists, physicists, experts in medicine, economics, governance, communication. We want to build a global community that believes in a better future. In fact, our byline is, we pursue an extraordinary tomorrow to create a better world today. It's all in the title of our proposal that won. An inclusive, audacious journey transforms life here on Earth and beyond. And this proposal that won this RFP from DARPA used the first word inclusive across gender, geography, and ethnicity, and also across disciplines. So our challenge is Interstellar, going beyond our solar system to another star. What does this mean? How is it different from going to Mars? Well, let's start off by something this person said in the 18th century, said, put 3 grains of sand in a vast cathedral, and that cathedral will be more full of sand than space is with stars. So here we go. Our closest neighboring star is Alpha Centauri, the Proxima Centauri system. And to grasp the scale of interstellar travel, the journey between stars, interstellar, let's use the relative comparison of the distances within the continental United States. Let's take Los Angeles and New York City. The distance between them is 2,944 miles, let's say. Think of Los Angeles as Earth and Alpha Centauri, New York City. Alpha Centauri is 4.2 light years away. The distance light travels in 4.2 years, 25 trillion miles. Let's get a feel for that. Light travels from the sun to the Earth in 8 minutes, and that's a distance of 93 million miles. The Voyager probes, which just left our solar system a few years ago, have been traveling at over 35,000 miles per hour since 1977. And if you consider how far they traveled on that Los Angeles, New York route, if they were headed toward Alpha Centauri, they would have only traveled 1 mile on that scale. It would take Voyager 50 to 60,000 years to get to Alpha Centauri if it was headed in that direction. So you see, we have to go a whole lot faster. We have to have a lot of other things too. We have to have radical leaps in knowledge, technologies, and human systems in order to achieve the capabilities for human interstellar travel. What kind of radical leaps? We need radical leaps in energy. Need different types of energy and propulsion because we've got to go faster. We don't have 60,000 years. We weren't cave painting well then. We need big data. We need clothing, sustainable agriculture, manufacturing breakthroughs, error detection, communication systems. We need to understand financial systems, health and medicine, human behavior, education, ecosystems. We need to understand the microbiome in the soil and in our body. But I want us to just look at the role of data in Interstellar. I want to call out some things about data. First one is navigation. Navigation, you have to recognize where you are in order to arrive at the place you want to be. And spacecraft use different methods to determine their position in 3D space, and space is really big. Right now we use a reference frame for many deep space. We use a reference frame for deep space probes that use the sun and the star called Canopus, which is about 300 light years away. But as you travel in space, we have to recognize that the number of stars is not insubstantial, and their relative position to you changes as you move. And going at relativistic speeds of 1% the speed of light, 2% the speed of light, means that a small error in measurement of calculation means a big error in position. Communicating, there's an issue of directionality, bandwidth, and coherence of information, right? We got lots to communicate back. We got to send back those postcards. So it means that we have to have a great line of sight pointing, and we have to be able to keep the data coherent, and we have to have great bandwidth. You know, while you're going along this, you need to be able to detect errors and correct them. Before you go, you need to understand the economic and the financial calculations. What do we get from the investment? How do we define and measure and calculate risk and reward? And the opportunities that may be gained or lost with regards to the capital we invest, the time we invest in doing something that's so radically different from what we know. Think about medical and health infrastructure when we start to think about data. Just the epidemiology on board to track disease and evolving human health systems. Therapeutic management, can we generate the therapeutics? Can we assess how they are? Can we build a pharmaceutical or physical therapeutics where we are? And say we're in suspended animation, are you going to trust your life support system to HAL, the computer? We have to have systems for monitoring food production, systems to monitor energy because we have to produce, store, and control and manage energy, vast amounts on scales that we have never done before in small spaces. We're looking at things like fission, fusion, antimatter, just to be able to go at the speeds we need to go. There's a lot more to consider. But I want to just spend a little time for saying, what does all that have to do with us today, right? What does the challenge of interstellar have to do with us? The challenge of human interstellar travel mirrors the challenges that we face in this world today. Every one of them, from energy to sustainability to behavior. And that's the focus of this conference. How do we use what we have to build a better world? So many people are looking at IT, big data, AI for solutions. But as we seek more data, I want us to recognize that there's a wicked truth about data, one that we have to take into account. Just because you have more data points doesn't really mean you have more information. You have to do something with that data. And just because you have more information, that's not the same as having knowledge. And having knowledge is not the same as having wisdom. There's something that has to happen to get from data to wisdom. Wisdom comes from the application of experiences, skills, empathy, perception, self-observation. Wisdom requires a 360-degree perspective over time and in an expanding universe of possibilities. And that's what the interaction with teams can help bring. That flexibility and that ability to evolve is also a hallmark of human systems and I believe humanity. That's the reason why we need teams. And before I continue, I have to make one observation, a growing trend that worries me. I'm just going to stop for a second. We spend a lot of time these days trying to build expert systems. And we interrogate human experts. We spend thousands and thousands of hours attempting to understand how these human experts operate. And then developers assume we know how the brain works, how experts and the very adept arrive at answers, questions, and solutions. And then we spend hours and years trying to get AI systems to replicate what we believe is the secret sauce, right? How these experts work. Yet it seems to me that we're spending less and less time working to expand the bountiful, remarkable, innate capabilities of humans and our mind and our capabilities. We don't tax ourselves. We have a naturally evolving system that has so much plasticity, capability from birth, and we are failing to do it. In fact, sometimes it seems like we're reducing what we call on it to do. We don't call on ourselves to memorize things anymore. I know somebody may have thought Luddite right there, but I'm perplexed because when we fail to use humans, we fail to use our entire solution set. Will and Ariel Duran said, the future never just happened, it was created. So we need to understand what we're creating as we pursue these things. You see, scientific technologies and advances don't come full form. They're not just sort of sitting in the sky waiting to fall out on top of us. It's how we decide to take advantage of our resources that's the crux of the matter. What science we research and what technology we develop depends on the people we are. It depends on our society. Do we use a certain combination of minerals to propel a bullet or to create a beautiful fireworks display? These are choices that we make. It's not born from the chemistry, it's born from our choice. The United Nations Sustainable Development Goals are really fairly modest. Look at them. End poverty in all its forms everywhere. Ensure access to water and sanitation for all. Sustainably manage forests, combat desertification, halt and reverse land degradation, halt biodiversity loss. These are just some of them. Build resilient infrastructure, promote sustainable industrialization, foster innovation, end hunger and achieve food security, improve nutrition, achieve gender equality and empower all women and girls. Take urgent action to combat climate change and its impact. These are just some of them. And I say they're modest because none of them really demand that we have more data or more capabilities in order to make a dent in them or to solve them. We know enough already. Certainly, we can always use more data. We can use more information. We can use better monitoring systems. We can do a better job, but the problem we have today is not lack of data, that we're not doing a great job tackling them. It's not lack of data. It's a problem with choice. Because from my point of view, the ability to make a moral conscious decision and to commit individually and as a society to choose a better reality are the critical challenges that we face in the world today. We have to choose to do better with our work. All the work that any of us does, whether we're with a company or whether we're doing it as an individual, whether we've completed our training or whether we're a student, the work that we do takes place in the context of what's happening in the world today and the changing requirements and goals of the world of tomorrow. And the context in which we work in today are diminishing resources, but abundance of knowledge and capabilities. But it's also impacted by people wanting to draw back in while at the same time they say they want to expand. We have to figure out how we're going to use these things. we have to also, importantly, figure out how we define success. The challenges to the world in which we work, live, and raise our children today and the future are about gaining knowledge and balancing it with wisdom and acknowledging that we have choice. And by having a broad perspective and a truly inclusive team, we can do a better job with all of that. I want to share with you a project of 100-year Starship. Now, I'd love to do projects that dazzle around considering relativistic speeds, right? Building biomimetic materials, creating medical infrastructures that we can take with us to the stars. But again, 100-year Starship isn't about building something that's going to launch in 100 years. It's about making sure the capabilities exist. So I want to share with you a much different, deceptively simple use of data. It's about connecting people across space and time. It's about helping us see ourselves as Earthlings and taking advantage of a small truth across societies. An African proverb says, "No one shows a child the sky." And so we decided to do Look Up, because all of us look up. It actually started with a discussion between LeVar Burton, Jill Tarter, and me over a quick snack at South by Southwest after we had introduced the world to 100-year Starship. We were talking about the ability of space to connect people with the Earth and each other. And how could we make that happen? Space could connect people even across generations. And after a number of years and bringing different people in, artists, data analysis, and other folks, Look Up was a result. Look Up, which debuted in 2018 as a single day, when we asked individuals around the world to record and share what they hoped, dreamed, feared, wanted, offered, wondered about when they looked up at the sky. And of course, we created an app for that. It was the Selfie app, Sky Selfie. The Selfie app allows users to create and seamlessly share audio, video, text, and photo contributions to a global sky tapestry. The tapestry is an interactive 3D globe, so it moves around, you can expand it, you can zoom in on things, and the sky selfies are uploaded in close to real time and are geospatially tagged and displayed on this globe. Around the world, individuals can view the selfies and see where they were generated, and they can see their own contributions to the world. They can ask, what were others thinking around the world during the same time I was loading my selfie? Our job at 100-year Starship was to make it easy to use and available. Everything can be done on a single Selfie app. That was our use of data. The Selfie app is also free, and it's available on iOS at the App Store, on Android at Google Play. We work with organizations to create different lookup events because our purpose is about connection. It is important for people to connect. When people connect, we're our most effective. Data reaches its full potential when it's widely disseminated, when it's generated by a diversity of people, and it's accessible by many. Facing our humanity and ultimately what it means that we have to connect. Progression of our ability is not just to tolerate one another, but to truly see ourselves in each other and expect and want the best for each other. There are 86,400 seconds in each day. And each one of those seconds is extremely precious because we can do with each of those seconds exactly as we please. But we can never get a single one of those seconds back. But to become who we intend to be, to have a world that is a world we want to lead, we have to have not only a vision of inclusion, but a commitment to bring the full spectrum of human experiences, skills, perspectives, talents to collecting and interpreting data. And we have to listen to them and hear them. Alongside of all of this, we have to bring hopefulness, self-responsibility, and courage, that we can find the wisdom to design and implement a path that will take us to a future in which we'll all be proud to live, and one that we will be happy to share with generations to come. Thank you.